Arrangements of passengers who board the bus at the terminal. So the number of seating arrangements, you only have 5 seating arrangements, 5 seats available, 5 seats available at terminal. Let's write this a little better. Only 5 seats are available at terminal. So only 5 seats are available at terminal because people don't board the bus before the terminal. All right, only 5 seats are available at terminal because the people them go on the bus before the terminal. And so the number of seating arrangement at terminal is just gonna be 5, 13 per mule 5. That's gonna be the number of seating arrangement possible at the terminal. 13 per mule 5, which is 154,440. Nice and easy. So now it says at the first stop, no passenger will get off the bus. So nobody now gets up gone away. But there are 8 other persons waiting to board the bus. Among those waiting are 3 friends who must sit together. They are definitely going to sit together. So 8 people are waiting to join. So I'm going to draw 1, 2, 3. These are the 3 friends, then they have to sit together. Then you have 5 people here. 1, 2, 3, 4, 5. So the number of possible groups of 5 of passengers who can join the bus. So there's going to be a group can be. So it's either 3 of them get to join and 2 person over here to join, or none of them here to join and everybody over here to join. All right. And so the number of ways is going to be, the number of ways is going to be equal to either all 3 of them join, and if all 3 of them join right here, so choosing these 3 from these 3 times, we're going to choose 2 from this 3 from this 5, so choosing 2 from this 5. All right, plus then if none of them here to join, then we're just choosing 5 from 5 here. So this would be 5, choose 5 times none of them from here, which is choosing 0 from the 3. All right, and that will give you the total number of possible groups of 5 people that can join the bus. It's either the 3 of them join and then 2 people over here, so, or everybody over here, so, and none of them over here, so, but the 3 of them from here have to go together halfway. So that's gonna be 3 choose 3 times 5 choose 2, that's 10, and 5 choose 5 is 1, and 3 choose 0 is 1, so it's 10 plus 1, 10 plus 1 is 11. That's the answer. Nice and easy. So next part of the question. Next part of the question says Gavin and his best friend Alexander are 2 of the 5 specialist batsmen on his school's cricket team. Given that the specialist batsman must bat before the non-specialist batsman and that all 5 batsmen may bat in any order, what is the probability that Alexander and Gavin are the opening pair of any given match. So this team, I like cricket, and this team, it said they only have 5 specialist batsmen. I can tell you that they lose already, unless they have a Virat Kohli and a AB de Villiers and a Chris Gale and a Kieran Pollard, then otherwise they're going to lose. Chris Gale, AB Pollard, Gavin, and Alexander, that must be the top 5 because they only have 5 specialist batsmen. So they have maybe 2 all-rounders and 4 bowlers. That's not the best lineup. So 5 of them, all right here. And we need the possibility of Gavin and Alexander opening. So we need Gavin and Alexander opening. What's the possibility of Gavin and Alexander opening? All right. So now to choose these two. So first, that means for Gavin and Alexander opening, that means we definitely the probability of the 2 of them opening. So the probability of Gavin opening and Alexander, I'm going to call it Gavin intersect Alexander. The probability of 2 of them opening is equal to, that means we're choosing these 2. All right, we're choosing these 2 from 2 times. That means we're choosing none out of these other 3. So we're choosing none out of those 3 divided by the total probability, which is choosing 2 from 5. That will give us the total possible opening combinations. And so that works out to be 2 choose 2, 2 choose 2 times 3 choose 0 divided by 5 choose 2. And so there's 1 over 10. So there's a 10% chance Gavin and Alexander will be the opening combination. So there is a 10% chance Gavin and Alexander will open next match. There's a 10% chance. All right, nice and easy, soft. That takes care of this question. Okay, now we get a matrix now. We have this matrix A, and they want to find the determinant of the matrix A. So to find the determinant of the matrix A, we're going to be using, I like to use something with a 0, so I'm using column 1. Using column 1, then the determinant of A will be 2 times the determinant of, if I cross out this here, it will be 4, 3, 0, 6. So I'll have 4, 3, 6, 0, minus 0, plus minus 1, plus minus 1, times the determinant of, if I were to cross this out, it would be 1 minus 1, 4, 3. 1 minus 1, 4, and 3. That's the determinant of A. And so the determinant of A is working out to be, that's equal to 2 times, now 4 times 6 is 24, minus 3 times 6, and that's 4 times 6 is 24, 24 minus 18 is 6, 2 times 6, which is 12, minus 1 times, now this is going to be 1 times 3, minus 4 times minus 1, That's 7. All right, good. So this works out to be the determinant of A is 2 times 6 minus 1 times 7. That's 5. The determinant of the matrix A is 5. Just want to check that again. 4 times. Oh, shoot, this was 0. I've been writing so bad that I confused myself. This was, let's go again. 4360. Oh my God, I was confusing myself. So look how I made an error. Let me write this better. This is 0. So this is not 6. 4 times 0 is 0. And so that's going to be 0 minus 18. This is minus 18. So this is now cross 3 minus, that's going to be 80 of 3 minus 4 times minus 1 is 7. This is minus 7. So now I can work this out. So my mistake. My apologies. 2 times minus 18 minus 1 times 7. That's minus 43. Just want to check it one last time. Cross out this and this. That would be 4360 times 2. That's minus 18 times 2 is minus 36. Good. Then I have plus minus 1 times, if I cross out that, then that would be 1 minus 1, 4, 3, which is 3. Minus minus 4, which is 7. That's minus 7. Minus 36 minus 7 is minus 43. Excellent. All right, so I get minus 43. That's good. So finish this now. Nice. It's a hence or otherwise find A inverse. All right, so first and foremost, since we're going to find A inverse, we just need to know that I'm just going to write it down around here, that A inverse is equal to 1 over the determinant, so it's 1 over minus 43 times the adjoint of A. Times the adjoint of A. All right, and in order to find the adjoint of A, we need to find the cofactor matrix and transpose it. So let's find the cofactor matrix. So let's find the cofactor of A. So the cofactor of A is going to be equal to, we're going to find the cofactor matrix. Determinant here minus the determinant here plus the determinant here minus the determinant here plus the determinant here minus the determinant here, determinant here minus the determinant here plus the determinant right here. Let's go ahead and find the cofactor. So first we go, and it's going to be cross here 4360. So put in here 4360. Go again around here. We cross out the 1, cross out here. That's going to be 0, 3 minus 1, 0. So we have 0, 3 minus 1, 0. And we go around here. Then we're going to have cross out here and here. We get 0, 4 minus 1, 6. 0, 4 minus 1, 6. 0, 4, -1, and 6. All right, we go around here. We're going to have cross out this 0. And we have 1 -1, 6, 0. We're going to have 1 -1, 6, 0. Then we're going to have cross here, 2 -1, -1, 0. 2 -1, -1, 0. 2 -1, -1, 0. Then we're gonna cross here. We're gonna have 2, 1, -1, 6. 2, 1, -1, 6. We go here now, I would cross here, 1 -1, 4, 3. 1 -1, 4, 3. Now go around here now. It's gonna be cross here. That's 2 -1, 0, 3. 2 -1, 0, and 3. Then finally, we cross here and cross here. So it's 2, 1, 0, 4. 2, 1, 0, 4. So now we can evaluate the cofactor matrix. And so the cofactor matrix is going to be equal to 4, 0. That's 0 minus 18. So that's negative 18. Then we get 0 minus 3 is plus 3. This works out to be -3. Then we have 0 minus 4 is plus 4. Then we have 0 minus 6. That's now -6. 2 times 0 is 0. Minus 1. 0 minus 1 is -1. And then we have 2 times 6 is 12. 12 minus 1 is 13. So that's -13. And then here we have 3 minus 4. 3 minus 4 is positive 7. Then we have 6 minus 0. That's now -6. Then we have 8 minus 0. That's positive 8. So that's the cofactor of A. If this is a cofactor of A, then A inverse is going to be equal to 1 over the determinant, which is 1 over -43 times the adjoint. And the adjoint is a cofactor transpose, so that's -18, -18, -6, -7, well, positive 7, -18, -6, positive 7, -3, -1, -6. Then we have 4. Then we have -13, -13. Then we have positive 8. Nice and easy. And that's A inverse. Nice and easy. That's A inverse. Soft. All right, nice. Now we reach question 6. We reach a final question on the paper. This year is the easiest pure math I've seen. So students who did this year, they were lucky. They said 2 fair coins and 1 fair dimes. 1 fair die are tossed. Calculate the total outcomes in the sample space. So the total outcomes is going to equal to the number of outcomes on each coin, which is 2 times 2 times the number of outcomes on the die, which is 6. So that's 4 times 6. 4 times 6, which is 24. So there are 24 outcomes, 24 possible outcomes on the sample space. Since it's just 24, I could list out all of them. I'm feeling a little bit, feeling in the mood to list out all of them. 24 is not a lot, and so I could list them all out. Yeah, let's list them all out. The 24 possibilities, if I were to list them out, would be, you could have head, you could have head, and then a 1. You could have head, and a 2. You could have a head, and a 3. You could have a head, and a 4. You could have a head, and a 5. You could have a head, and a 6. You could have maybe those are all possibilities of getting a head, then a head, then a 1. Then maybe you get a head, then a tail, head, then a tail, then a 1. Maybe you get a head, then a tail, then a 1. Or maybe you get a head, then a tail, then a 2. Or maybe you get a head, then a tail, then a 3. Or maybe you get a head, then a tail, then a 4. Or a head, then a tail, then a 5. Or you get a head, then a tail, then a 6. Those are for right there. Or maybe you got a tail, then a head, then a 1. Or you get a tail, then a head, then a 2. Or you get a tail, then a head, then a 3. Or you get a tail head on 4. Or you get a tail head on 5. Or you get a tail head on 6. Or maybe you're just not good and you get 2 tails and a 1. Or you get 2 tails and a 2. Or you get 2 tails and a 3. Or you get 2 tails and a 4. Or you get 2 tails and a 5. Or you get 2 tails and a 6. All right, so that's what, these are all the possible outcomes. All right, all possible outcomes. So those are the 24 possible outcomes. If you wanted to show them like that. Nice and easy, soft. Now it says, find the probability of getting exactly 1 head. The probability of getting exactly 1 head from here is the chance of getting 1 head, as you can see, out of the 24. Well, exactly 1 head. So the probability of getting 1 head, so the probability, so it's pretty much asking you for the probability of getting 1 head. The probability of getting 1 head, that's just going to be equal to, on the first die, you'd have to get a head, which is 1/2. That's the probability of getting a head, times, you need to get a tail now. You need to get a tail. This would be the probability of getting a head, and the probability of getting a tail now, probability of getting a tail is 1/4 times the probability of getting anything else. So it's a chance of getting 1 head, chance of getting a head on the first die, all right, times the probability of getting a tail times anything else, which is 1, plus the probability of getting a head on this, on the other dice, so it would be 1/2 times 1/2 times 1. All right. You might wonder what this half means. This just means probability of getting a head. Remember, you know, you have either head or tail, so there's 1/2 chance of you getting a head. So you can get a head, a tail, and then I put times 1 because it doesn't matter if you get a 1, 2, 3, 4, 5, or 6. Then over here, so you can get a tail, then a head, and say work this out and you get 1/4 plus 1/4, which is 1/2. So there's 1/2 chance of you getting exactly 1 head. All right, and see it there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 out of 24 chances of you getting one head. Getting one head. All right, so there's half a chance of you getting one head. That's how you do it by calculation. This is by the sample space. It says calculate the probability of obtaining at least one head on the coin, obtaining at least one head on the coin, and an even number on the die. So they want this. The probability of getting one head and an even number. This is one head and even number, one head and even number, one head and even number, 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 head and even numbers. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could tell them from sample space, chance of getting one head and an even number is, from the sample space, you could tell them that the chance of getting one head and the even number is 9 out of 24. And 9 out of 24, that will work out to be whatever you want that to be. 9 out of 24, which is 3 over 8. All right, 3 out of 24. That's the probability of getting one head and an even number. Now, the next thing it asks for, well, let's say you didn't put out the sample space. I'm going to do the calculation for those who didn't draw the sample space. Let's say we're doing it by calculation. So the probability of getting one head, just for those who didn't do the sample space, once it's less than 30 sample points, I highly recommend drawing the sample space. But to get one head and an even number, all right, one head and an even number. The probability of getting at least one head is, these are independent events. The chance of getting at least one head is going to be, probability of getting at least one head, this would be 1, let's see, 6, 12, 18 out of 24. The chance of getting at least one head is 3/4. All right, the probability of getting at least one head. You might wonder, how do I know that? Getting at least one head, you can either get tails, or you can get tails, which is one head, or you can get head, or you can get tail. All right. And so at least one head is going to be 3 out of 4. So it's 3 out of 4 if we get one head times the probability of getting an even number. There are 3 even numbers from 6 numbers. And so this simplifies down to be 3 into this 1 time, 3 into this 2 times, so you get 3 over 8. And that's how you do it. Any way you prefer to do it is fine. All right, nice and easy. Soft. Now let's look at part B. Part B says, determine whether C1x plus C2x squared is a solution to the differential equation x squared over 2y double prime minus xy prime plus y equal to 0. So to determine whether this is a solution, first thing is we start with what's given. We need to see if it's going to satisfy this equation. So we know y is equal to C1x plus C2 plus c2 x squared. That is y. All right, let me rewrite this better. So we can find the first derivative, y prime, and y prime is going to be equal to differentiate c1x to get c1 plus, that's going to be 2c2x, 2c2x. Then we differentiate this again to get y double prime. Y double prime is equal to, we differentiate 2c2x. We differentiate 2c2x, we're going to get 2c2. Nice and easy. All right, and now it says determine whether this is a solution to this differential equation. And so all we need to do is simplify. All we need to do is now substitute for y double prime and y prime and y to see if it will satisfy this equation. If it does, then it is a solution to the differential equation. So we're going to have x squared over 2 times y double prime. So it's x squared over 2 times 2c2. Now 2c2 times x squared over 2. See that those 2's cancel. Minus x times y prime. X times y prime will be x times c1 is going to be c minus c1x. Then this becomes minus 2 c2x. Then you have plus y, which is plus, and y is just c1x plus c2x squared. Whoa, that came out nasty. Plus c2 x squared. As we can realize, this 2 cancels this 2, and then x squared c2 and x squared c2, those cancel each other, plus well, xc2, x squared c2. Well, let me see first if those actually cancel. I'm not gonna just jump and make that conclusion. All right, just want to check if I differentiated things properly. Okay, c1x, c2x squared, differentiated to get c1 plus, this is 2c2x. Differentiate this, we get 2c2. Y double prime times x squared is 2x squared over 2c2. That's good. All right, then minus x times this will become minus x c1 minus 2. Aha. Okay, I see. When I multiply this part by minus x, I get minus 2c2x squared. Because remember, x is being multiplied by this, plus c1x plus c2x squared. All right, so this is what I get. So now it works out, yes. Because now this x squared c2 plus x plus c2x squared, when I add those two, c2x squared plus c2x squared will give me 2c2x squared, and the minus c1x plus the minus c1x cancel, and so I get 2c2x squared minus 2c2x squared is equal to 0. This is indeed equal to 0. Answer yes. So now we can conclude yes. So we can conclude yes. Yes. Yes what? y, which is equal to c1x. Yes, we can conclude that y, which is equal to c1x plus c2x squared, is a solution to the differential equation. Is indeed a solution to the differential equation. Nice and easy. So we've shown that quite easily. All right, so we're done with that question. We didn't have anything really to do here. Next part of the question, it says, show that the general solution to the differential equation is given by y, which is c times the cube root of x squared plus x all square rooted. Show that this is a solution to this differential equation. So, all right, now let me see. This looks a little weird. So what we have is 3 times x squared plus x, 3 times x squared plus x, I'm going to cross multiply the dx. Just for now, I'm going to write it as y prime, and that's equal to 2y times 1 plus 2x. So I'm writing it as 2y times 1 plus 2x. And I said I cross multiply the dx. And I'm going to write the dx as x prime. All right. Yeah, man, so we're good. All we need to do is divide both sides. So I'm going to divide by 2y and divide by 3 times x squared plus x. Okay. So I divide by 2y over here to get 1 over 2y times y prime. And that would be equal to, this is going to be equal to 1 plus 2x over 3 times, instead of saying x squared plus x, I'm going to write it as x plus x squared. And it may say, sir, why? I'm going to do that because I noticed that if I do it this way, I can easily identify the differential of the denominator is in the numerator. So what does that mean? That means I can then go ahead and integrate both sides with respect to each variable. We can factor out this half, and so the integral of 1 over y dy is ln y. So this is ln y is equal to, and remember I factored out the half, so it's really a half ln y. So a half ln y is equal to, now I can factor out 1 over 3, and the differential of the denominator is in the numerator. And so it becomes 1 over 3. The differential of the denominator is in the numerator, so it's 1 over 3 ln x plus x squared. And anytime you integrate, you add your constant of integration. X plus x squared plus your constant of integration plus c. Nice and easy, solved. And so now we may continue. In continuing, what we can do is bring up, let me see, we need to make y the subject and y should be this. So to do that, what I'm going to do is, I'm going to rewrite this as ln y to the half power, which is the square root of y. So ln the square root of y is equal to, I'm going to bring up the 1/3 power and write this as ln, maybe this will work. I'm going to write it as ln the cube root, because I bring up the 1/3 power, so it's ln the cube root of x plus x plus x squared plus, now this c right here, now I need to get this in terms of a ln2, so I can just add them. So let me see, and I'm just going to say this can be rewritten as, instead of writing a constant as c here, I'm going to write it as, call it c1, then plus ln c, where ln c is equal to, I'm just going to call this plus c, ln c. All right, nice. So now I can continue. So that implies, by using laws of logarithm, I'm going to get that the square root of y must be equal to ln a plus ln b is ln ab. All right, and so the square root of y must be equal to, it's going to be c times the cube root, c times the cube root of x plus x squared. All right, okay, nice. Now to make y the subject, I need to square both sides. But how did they get the square to be inside here? That's the issue. What did they do to get the square inside here? Let us determine that. Because what we're getting is the square root of y. Ah, I see how they could have gotten that in there. All right, we should have done it from right here. We should have multiplied through by 2. We should have multiplied through by 2. Okay, we can do that from here. So let's refix this. Let's just see how they got it. This was a nice paper. Nice question. So instead of doing this, we're going to multiply through by 2. We're going to multiply through by 2. This will become multiply through by 2. We're going to get ln y is equal to, when you multiply through by 2, you're going to get, just fixing this up now. We're multiplying through by 2. Why didn't that erase? Let me try again. And so if we multiply 2 by 2, we're going to get 2 over 3 ln x into x squared plus 1. So x plus x squared plus, instead of saying c1, we're going to write plus ln c. That's still a constant. We can write ln c, where c1 is ln c. So now we can bring up the power to write that ln y is equal to, bring up the 2/3. Anything to the 2/3 can be written as, this is now ln squared cube rooted. This is now ln the cube root of x plus x squared all square x plus x squared. So it's the cube root of x plus x squared plus ln c. And then by laws of logarithm, we know that we can join those together, because if the log of a is equal to the log of b plus the log of c, we can join them as one log to say this implies that y is equal to, first, remember the sum of the log, this is really log a, but let me not skip any step, then this is just ln y is equal to, adding the two logs, we can rewrite it as a log of c times this. So it's a log of c times the cube root of c times the cube root of x plus x squared cube root of x plus x squared all square all right, x plus x squared. So it's c times the cube root of x plus x squared and then we can say if log a is equal to log b, then a must equal to b, and so y must be then equal to c times the cube root of x plus x squared all cube rooted, x plus x squared x plus x squared all square cube rooted. Nice and easy. That's how we get y. Nice. The last part of the question says, given that y of 1 is equal to 1, solve this differential equation. Given that y of 1 equal 1, now y of 1, this is y. So that means when x is 1, y is 1. So let's start by writing that. Remember, so when x is 1, y is 1. When x is equal to 1, that's what they're telling us, y is equal to 1. So all you have to do is substitute in the equation. And remember, they told us that y is equal to c times the cube root of, y is equal to c times the cube root of x plus x squared all square and so all we need to do is substitute x and y as 1. So substituting x and y as 1, we're getting 1 is equal to c times the cube root of, no, 1 plus 1 is 2, 2 square is 4, 1 plus 1 square is 1, 1 plus 1 is 2, 2 square is 4, so we want the cube root of 4. So the cube root of 4 times c is 1, so we divide by the cube root of 4, and so c is equal to 1 over the cube root of 4. So we work out what that is. Cube root of 4 can't I simplify it any other way? Let me see if I can simplify it without using a decimal. Let me see. I can rewrite 4 as, this is really 2 square, 4 is 2 square, raised to the 1/3 power. Can't I write this any other way? Let me see. This is c. Alright. Didn't want to put it as a decimal. This is 4 to the 1/3. Anyway, I can rewrite this in a pretty way. Well, I don't seem to at this moment. So 2 squared raised to the 1/3. 1 divided by that. I'm getting 0.0 629 0.629. That is C. So since that's what I'm getting for C, I can finally write down my solution of this differential equation. And so y is equal to 0.629. Y is equal to 0.629 times the cube root of not again, cube root of x, where did that dissipate to? That is x plus x squared all square. Nice and easy, soft. I really hope this was entertaining for you as it was for me. This was so entertaining. I had a lot of fun, and so I hope this would have helped anyone practicing the 2016 paper. And stay tuned for more. Make sure to just hit that subscribe button